Welcome to Module 2, Lesson 5. We are going over quadratic functions and inequalities. To prepare for this lesson, you need to be able to state the domain and range from a graph, as well as to be able to solve quadratic equations. The learning objectives are to graph quadratic equations in two forms, vertex and standard, to be able to solve application problems involving quadratic equations. And then the second half is going to be about solving quadratic inequalities and solving application problems involving quadratic inequalities. I'm guessing you've used this QR code, so thanks for joining us. But as a reminder, you can pause and rewind this video as often as you need, so this lecture is at your own pace. And then look at your course schedule to see when this lesson's homework is due. So I actually want to go ahead and jump into the next page and go over this information. So I already have this filled out. You can either fill it out as I'm talking or pause the video and get this copied down. Your homework is not really going to ask you too often to determine whether the parabola opens up or down, but it is a good thing to know. So if your A, remember your quadratics are in the form of ax squared plus bx plus c. If your A, that leading term or coefficient, is greater than 0, your parabola is going to open up. And so you can see here is a diagram of your parabola opening up. You have that axis of symmetry that makes the left side mirror the right side. And wherever this vertex is, that's going to be the lowest point on that graph. If A is less than 0, or if A is negative, if you have a negative out front of your quadratic, it's going to open down. So here's a quadratic that is opening down. Now that vertex is going to be the highest point on that graph. We still have that axis of symmetry, which makes the left side mirror the right side. And so whenever you start, it's just a good idea to make sure you know which way it's going to open. That way, if you determine it's opening up and for some reason yours starts opening down, reevaluate what you have done. Now, a big thing that we're going to be asking you in this lesson is to determine the x-intercept. So it says, given a quadratic equation, to find the x-intercept, if there is one, we need to let our y or f of x equal 0 and solve for x. So there are 3 different ways that you are going to solve for x. You can solve by factoring, quadratic formula, and square root method. I put over here on the side kind of the best times to use each of our techniques. When we are given vertex form, I would recommend using the square root method. But if we're in standard form, you want to use factoring and quadratic formula. And so this will make more sense to you as we go further on into the videos, but not a bad little nugget to write down and keep in mind as we go forward. Now, talking about those x-intercepts, we could have 2 x-intercepts, 1 or none, depending on what this graph looks like. So I would say typically it's probably going to look like this, where it crosses twice, where if it opens up, that vertex is below the x-axis, or if it's opening down, that vertex will be above the x-axis, and then it will cross 2 different places. So when you are factoring, when you're using the quadratic formula, when you're using the square root method, graphically, we showed this, and we did this in class and in the video 2 lessons ago. We were verifying our answers by checking, is that where it's crossing the x-axis? You can also have where that vertex is on that x-axis, and when that happens, it doesn't cross through it, but it just simply touches. And when it touches, that vertex will be the 1 x-intercept. Now, we talked about this too. When a graph does not cross the x-axis, that's when we got those imaginary answers. So if you are using, well, you can't get an imaginary answer using factoring, but if you're using quadratic formula and square root property and you get a negative under a radical, which means you get an imaginary number, then that means the graph does not have an x-intercept because it's either all above it, like this one here, or it's concave down and even that vertex is below that x-axis. So it's just not touching, it doesn't have an x-intercept. So 2, 1, none. And then the other big thing we're going to ask you is to determine the y-intercept of a parabola. So exactly the opposite. If you're given a quadratic equation, to find the y, you let x equal 0 and solve for your y or your f of x. Because we're talking about functions here, there will be exactly one y-intercept on every single graph, whether it has 2, 1, or none x-intercepts. So here you can see it's crossing that y-axis. Here, it's crossing over here. This one, if this line went up and this graph went up, it would eventually cross that y-intercept. So it does not matter if it's concave up, concave down, does not matter how many x-intercepts it has, whether it's none, 1, or 2, it will always, always, always have one y-intercept.